Now all of you see here. In the previous lecture, I have told you about the law of flotation. What is the law of flotation? According to the law of flotation, weight of floating body is equal to the weight of liquid displaced by the immersed part of the body. Weight of floating body will be equal to the weight of liquid displaced by immersed part of body. Now this thing is also known as here. This thing is also known as upthrust. Weight of liquid displaced by the immersed part, that is also known as upthrust. Is clear? So this is the law of flotation. In terms of symbol, we can write it in this way: V into rho S. Rho S means density of solid. This is what? This is the density of solid into G equals to small b into rho L into G. What is rho L? It is the density of the liquid in which the body is floating. It's clear? What is capital B? It is the volume of the body. Small v, it is the volume of the liquid displaced. All of you see here. Small v is the volume of liquid displaced, which is equal to the volume of immersed part of body. Volume of immersed part of body. This is known as volume of immersed part of body. It is clear? Now see here. If the body is completely immersed, if it is completely immersed, then small b will be equal to capital B. Small b will be equal to capital B. So all of you remember law of flotation in terms of the symbols. Law of flotation in terms of the symbols. You can see here what is the law of flotation in terms of symbol. This is given here. It's clear. You can see here. It is just you remember V into rho S into G equals to small v into rho L into G. This is the law of flotation in terms of the symbol. Then you can see here we can cancel G in both the sides. When you will cancel G in both the sides, what will you get? So see the next page. You can see here on simplifying. When you will cancel G and rearrange the term, you bring rho L, this thing, in the left hand side. So rho S upon rho L equals to small v upon capital V. What is small v? It is the volume of immersed part. Capital V is the total volume. Small v is the volume of immersed part. Capital V is the total volume. Now what does it mean? इसका मतलब क्या है? इसका मीनिंग है फ्रैक्शन ऑफ बॉडी इमर्स्ड इन लिक्विड. Fraction of body immersed in liquid during flotation. Volume of immersed part upon total volume means what fraction of body is immersed in liquid during flotation. Means rho S upon rho L equals to small v upon capital V. What is small v upon capital V? Small v upon capital V means it is the fraction of body immersed in liquid. It's clear? Now see here, if this liquid is water, then rho L can be replaced by rho W. Rho L means can be replaced by rho W. Rho is a Greek letter, RHO. It's clear. Rho is a Greek letter. So rho L can be replaced by rho W. So what will happen? Rho S upon rho W equals to fraction of immersed portion. And what is rho S upon rho W? RC. Density of solid upon density of water. RC Srivastav. You answer this. Rho S upon rho W, density of solid upon density of water. This is known as Ashish Srivastav. My audio is reaching or not?
Yes, sir.
Yes, sir.
So what
Hello?
will be rho S upon rho W?
Sir, solid of density. Density of solid.
It will be the relative density of the solid. It will be the relative density of solid. What is the formula of relative density? It is the density of solid upon density of water. Means relative density of solid equals to fraction of immersed portion of body during flotation. Fraction of immersed portion of body during flotation. It's clear. You can see here. Here you can see. Here I would deduce that relative density equals to density of solid equals to fraction of solid immersed in water. Immersed in water during flotation. During flotation. Now suppose this is a body. Here this is the body and it is floating in water. It is floating in water. This is the container containing water. And it's this much portion is immersed. This much portion is immersed. You can see here what is the fraction. So you can see here total parts are, you can see 1, 2, 3, 4, 5, 6, 7. Out of 7 parts, how many parts are immersed? Who can tell? Out of 7 parts, how many parts are immersed?
Sir, 4.
कितनी पार्ट तक डूबी है ये? Can you tell me?
Sir, 4 parts.
Sir,
4
4
parts. So what will be the fraction of immersed portion? Fraction of immersed portion will be 4 upon 7. It's clear? So what will be the RD? RD equals to, you can see, fraction of immersed portion, that is RD will be 4 upon 7. Adi, what will be the density here? Adi,
Yes, sir.
what will be if RD is 4 upon 7, then what will be density? Vikas Chaturvedi.
Sir, 4 by 7 gram force.
Gram per centimeter cube. 4
Yes,
upon
sir.
7
Yes, sir.
gram
Yes, sir.
per centimeter cube. It is clear? You take one more example here. Here I am giving one more example. You see here. Here there is a container containing liquid. It's clear. And you can see here, this is the solid here. Here 1, 2, 3, 4. What is the fraction of immersed portion? Who can tell?
Sir, 2 by 4.
2 by 4 means 1 by 2. So what will be RD? Here it is water. It is water. So RD will be 1 by 2. So what will be density?
Sir, 1/2
Density
gram per centimeter cube.
gram per centimeter cube. So all of you remember this thing. RD of any solid equals to fraction of emerged portion. Emerged portion during flotation in water. In water. It's clear? Fraction of emerged portion during flotation in water. It's clear? In symbolic form, we remember this as rho S upon rho L equals to small v upon capital V, which I have already told. Now you can see the numericals now. So some numericals are very simple here. One more thing you will remember, 1 gram per centimeter cube equals to 1000 kg per meter cube. Akhand Pratap, what happened to you? I am going to remove you. Now see here question number 1. All of you see in your book question number 1. A rubber ball on water with its 1/3 volume outside water. So when 1/3 is outside water, so what will be the volume of immersed portion? What will be the fraction of immersed portion? It will be 1 minus 1/3. 1/3 is given outside water. So how much is inside water? 1 minus 1/3, that is 2/3. Means rubber ball is floating in water with 2/3 portion immersed. So what will be the RD of rubber ball? It will be 2/3. Just now I have told RD of ball equals to fraction of immersed part in water. So it is 2/3. So what will be density? Density will be 2/3 gram per centimeter cube. Or if you convert in kilogram per meter cube, then you will multiply by how much? 1000. So it will be 2/3 into 1000, that is 2000 upon 3 kg per meter cube. 2000 upon 3 kg per meter cube, that is 667. Whether it is clear? This question is clear?
Yes, sir.
Now you see the numerical 2. A block of wood of mass 24 kg. Here its mass is given 24 kg. And the volume is 0.032. Find the volume of block below the surface of water. Volume of block below the surface of water means small v you have to determine. You have to determine this value, small v. It's clear? What is the value of small v? So see here, how will you determine small v? So as we know that from law of flotation, weight of floating body equals to weight of water displaced by immersed part. So what is the weight of floating body? Mass is given 24 kg, therefore weight will be 24 kg. Mass is given 24 kg, therefore weight will be 24 kg. You can see. Mass is 24 kg, therefore what is the weight? Weight is 24 kg. So weight of floating body is 24 kg. Weight of water displaced. So you can see here the immersed portion is this. This is the immersed portion. So small v into density of water, and if you don't write the value of g, then we can write in kgf. अगर g की वैल्यू लिखेंगे तो आंसर will come out in Newton. But if you remove g, then you can write in kgf or in gram force according to the density of water. So here density of water we have taken 1000. So it will be 24 equals to V into 1000. So what is V? 24 upon 1000, that is 0.024 meter cube. This is the volume of immersed portion. Then you have to find the density of water. How will you find density of water? You can see a density equals to mass upon volume. Density equals to mass upon volume. So you can see here, density of wood equals to mass upon volume, that is 24 divided by 0.032. When you will simplify, it will come out saving 50 kg per meter cube. Saving 50 kg per meter cube. It will come out this much. It is clear? Now you can see here. Then after this, you can see the question number 3. A wooden cube of side 10 centimeter. Cube means whose length, breadth, and height, all the three are same. Here, this is the, you can take one side, this is the another side, and this is the third side. All the three sides will be equal. Though in this diagram, here all the sides are not equal. So a wooden cube of side 10 centimeter has mass 700 grams. What part of it remains above the water surface while floating vertically on water surface? So you can see here, this is the wooden cube. What will be the cross section? Cross section will be this shaded part is the cross section. This shaded part which I am shading here, that is called the cross section. This part is called cross section. It's clear, you can see. What will be the volume of cube? Area of cross section into length. Area of cross section into length. Here cross section will be throughout same. So you have to find how much portion is immersed. How much portion is immersed above the water surface. So you find out the immersed portion volume. What is the volume of immersed portion? So we have assumed that volume of length of immersed portion is L. So what will be the volume of immersed portion? Who can tell? If we take length of immersed portion as L, then what is the volume of immersed portion? Can you tell me? If we take
Sir,
length
above the water.
length of immersed portion as L, then what is the volume of immersed portion?
Sir, capital V minus L.
See, this is the volume of immersed portion which I am showing here. This is the volume of immersed portion. This part is underwater. This part is underwater. It's clear. What will be its volume? Length into area of cross section, which is same. Length into area of cross section. So small l into capital E. Now area of cross section, it will be 10 into 10 because in cube all the sides are equal. So it will be 100 centimeter square. It's clear. So what will be the total volume? Total volume will be the total length into area of cross section. that is equal to 1000 centimeter cube. It is clear? Now, what is the volume of immersed part? It is small l into area of cross section, which is 100. Small l into area of cross section. Area of cross section is 100. That is 100 l. It's clear. So you apply the law of flotation. Small v upon capital V equals to rho s upon rho w. What is small v? Small v is 100 l. What is capital V? It is 1000. So you substitute here. You can see 100 L upon 1000. What is the density of cube? Density of cube will be mass, because here rho s is what? It is the density of cube. This you have to determine. What is rho s? Rho s is the density of cube. So density of cube equals to its mass divided by volume. Volume already you have determined. What is the volume of the cube? You can see here volume of cube is 1000 centimeter. 1000 centimeter cube. So it will be equal to how much? 700 is mass upon 1000, that is 0.7 gram per centimeter. Now you substitute the values in this formula. Small v upon capital V equals to rho s upon small v upon capital V equals to rho s upon rho w. Here we have placed the value. So small v 100 L upon 1000. Rho s is 0.7 upon rho w 1 gram per centimeter cube. It is 1 gram per centimeter cube. So 100, this will be L upon 10. When you will simplify, it will come out 7 centimeter. 7 centimeter is below the water. So what is the length above the water? It is 3 centimeter. Length above the water will be 3 centimeter. Now you see the next question. This question is directly based on the formula. You can see here, question number 4. A piece of wax floats on brine. Wax piece is floating on the brine. What fraction of volume is immersed? So what is the formula? Fraction of immersed portion equals to wax is floating, so rho wax upon rho brine. What is the density of wax? 0.95. Density of brine 1.1. 0.95 upon 1.1, that is 9.5 upon 11. Therefore, it will come out 0.86. This question is clear. Question number 4. Here you have to find the fraction of wax immersed in water. So it is 0.86. It's clear? Now see the next question, question number 5. If the density of ice is 0.9 gram per centimeter cube, what portion of an iceberg will remain below the surface of water? Density of seawater is given 1.1. So here also fraction of iceberg below the surface of water. Below the surface of water. It will be equal to density of ice upon density of water. Substitute the value, it will come out 9 upon 11. 9 upon 11. It is clear? This thing is clear?
Yes, sir.
Yes, sir.
See the next. What is the next question, Asi? You tell me. What is the question number 6? You read this. Read the question number 6. A piece of wood of uniform cross section and height 15 centimeter floats vertically with its height 10 centimeter in water and 12 centimeter in spring. Means जब ये वाटर में फ्लोट कर रहा है तो इसका कितना इमर्ज पोर्शन है? It is only this much part is immersed. You can see here when it is floating in water, then only this length is immersed. What is the total length? This total length is given 50. Here we have taken area of cross section as A. This shaded portion is the area of cross section. It is clear? So what will be the total volume of this cube? Who can tell? Total volume.
A into 15.
Length into area of cross section. There is the formula of volume. Volume of cuboid equals to, I'm writing here, of cuboid equals to length into area of cross section. Cross section. And cross section means that surface which is above the, which is perpendicular to the length. It's clear? You can see here. Volume of cuboid equals to length into area of cross section. Cross section is this. So what will be the total volume? 15 into A. What is the volume of immersed portion? 10 into A. Volume of immersed portion will be 10 into A. This thing is clear? So see here, you use this formula. Small v upon capital V equals to rho S upon rho W. When it is floating in water. In water, it is floating with 10 centimeter immersion. So small v 10 into A upon 15 into A equals to rho S upon rho W is what? It is 1 gram per centimeter cube. So when you will simplify, you will get the density of the solid. It is 2 by 3 gram per centimeter. 2 by 3 gram per centimeter cube, that is 0.667. Now see here, when it is floating in the brine solution, how much portion is immersed? This length is 12 centimeter. When it is floating in the brine solution, what is the length of immersed portion? Length of immersed portion is 12, which I have taken as 10. That is actually 12. It's clear? You can see here. Now this length is 12. Here this length is 12. So what will be the immersed portion volume? 12 into E. So once again, when floating in spirit or in spirit, not brine, it is in spirit. So small v upon capital V equals to rho S upon rho spirit. So what is small v? 12 into A. Capital V 15 into A. Rho S already you have determined density of solid 2 upon 3. We will not put in 0.667. And why? Because it is not terminating. It is not terminating. So we will write in fraction 2 upon 3. In place of rho S, what will you write? 2 upon 3 into rho spread. Simplify this, you will get the answer 0.833 gram per centimeter cube. So I hope that it will be clear to you. Now see the question number 7. 7th question is also same as this. It's clear? You can see the question number 7. 7th question. A wooden block floats in water with 2/3 of its volume submerged. How much is the fraction of immersed portion? 2 by 3. Small v upon capital V equals to 2 by 3. So it will be equal to rho wood upon rho water. You substitute the value. What will be the rho wood? Rho wood will be equal to, when you will simplify this thing, here you have substituted the values here. Small v upon capital V is given 2 upon 3. So rho wood upon 1000. Here I have taken density of water in kilogram per meter. It's clear? So 2000 upon 3. On simplifying 2000 upon 3, that is 667. 667 kg per meter cube. Now when it is floating in IL, so it is given when it is floating in IL, then 3/4. 3/4 means 3/4. Its volume is emerged. So small v upon capital V is now 3 upon 4. Rho would already you have determined 2000 upon 3. You can see here rho would be 2000 upon 3. So you substitute here 2000 upon 3 into rho IL. So rho IL will be equal to 8000 upon 9, that is 889 kg per meter cube. Now question number 8. Here density of ice is given 0.92 and that of seawater 1.025. And it is also given when it is floating in water, it's 800 centimeter cube is above water. 800 centimeter cube is above water. You have to find the total volume. How will you find total volume? So you assume that total volume is V. When total volume is V, then what is the volume of immersed portion? Who can tell? Total is V, 800 is outside, so immersed part is V minus 800. So from law of flotation, you can see, you apply this small v upon capital V equals to rho ice upon rho water. Small v is V minus 800. Capital V is this. You substitute the value, cross multiply, you will get the capital V. Here I am not doing the calculation. Calculation I am not done. Now you see the last question. Last question, all of you see in your book. A weather forecasting plastic balloon of volume 15 meter cube. Its volume is 15 meter cube. It is filled with hydrogen of density 0.09. Filled with hydrogen of density 0.09. So what will be the volume of hydrogen? It will be equal to 15 meter cube. So mass of hydrogen will be volume of hydrogen into density of hydrogen. That is 15 into 0.09, that is 1.35 kg. Then you have to find the mass of hydrogen and balloon. Here it is given that the balloon is weighing 7.15 kg. Means what is the weight of its fabric? Weight of its fabric is 7.15 kg. So what is the mass of hydrogen plus balloon? It is 1.35 plus 7.15, that is 8.50. 8.50. Then it is also given that there is a x kg. There is an equipment whose mass is x kg. This is the equipment and its mass is taken x kg. So what is the mass of balloon plus hydrogen plus equipment? Balloon plus hydrogen plus equipment. So balloon plus hydrogen is 8.50. Equipment is x, so 8.50 plus x. Now what will be the volume of air displaced by the balloon? Volume of air displaced will be equal to volume of balloon, that is 15 meter cube. So what is the mass of air displaced? Mass of air displaced is volume multiplied by density of air. That is, density of air is given in the question, so it is 19.5 kg. Now you apply the law of flotation. From law of flotation, weight of balloon plus hydrogen plus equipment equals to weight of air displaced. Weight of balloon plus hydrogen plus equipment is 8.50 plus x, and weight of air displaced is 9.5. So what is x? 19.5 minus 8.5, that is 11 kg. So what is the mass of equipment? 11 kg. This is the mass of equipment.